Yeah, may I start?
Yes, yes, you can start.
Yeah. So I'm Abhay Prasad from second year AI. So I am going to explain about genetic algorithm and machine learning today. So genetic algorithm is based on Charles Darwin's survival of the fittest. It's nowhere related to biology. So these are the key terms we will be going on in this presentation. So we have population, chromosomes, gene, alleles, fitness function, genetic operation, and selections. So population is a subset of all possible or probable solutions which you can solve in a given problem. So there'll be a given problem which you need to optimize it. So set of all the possible solutions for that problem is in the population. So you just take this whole set which is given is the population, and one of it is the chromosome. So one list in it is a chromosome, and one part of chromosome is gene, and the value of the gene is called an allele. So the fitness function is used to determine how fit the allele is, like how fit the value of the gene is. So at every so after every iteration, we check the fitness function to see if it is uh, to see if it is valid for the next iteration or not. So there'll be genetic operators again. In in a genetic algorithm, the best individual mate to generate offspring is better than the is better than parents. Matlab, so we generate the fitness function, and then from the fitness function we generate an offspring population which will be compared to the previous population. So there are a few methods which we have to generate an offspring from the given population. So we'll be using genetic operators for that. So there are different types of selection to create an offspring population. So a few of them are roulette wheel selection and event selection and rank grounded selection. So we calculate the fitness function, and based on the fitness function, we cross over or we mutate, or matlab we change a few parts of the we change the few parts of the population, and then we create a new population. So this is the structure of the algorithm. First, we initialize the population, then we select individuals for the mating pool. Like uh, like we select the chromosomes for the mating pool. We take two chromosomes, perform a crossover, and then mutate them if it's necessary. Then we insert the offspring into the population, and then we iterate it until we get the most until we get the termination value, I mean the most desired value. So I have a small demonstration that will demonstrate this. So, yes, good. Yeah. So this is the demonstration. So so first what I did is I defined a calculation, a function called calc, which will take three inputs x, y, and z, and will and which will return this and which will compute a and return a as the output. So our goal is to find the values of x, y, and z which will give a as 0. So we define a fitness function with x, y, and z as its parameters, and we calculate and we calculate the function, the answer of the function given as ans equal to calculate of x, y, and z. So if answer is equal to 0, we return 99,999, which is the highest value. Otherwise, we return absolute value of 1 by answer. So this is like If answer is not equal to 0, like if answer is like somewhere around 0, the 1 by answer will be a high value, which means we'll get like which means higher the fitness, the higher the probability that the answer is equal. Higher the probability that the answer is correct. So we create and initialize a population. That means generate a random set of solutions. So I've made a list called solutions for then. So I've taken I'm generating 1,000 solutions for each one. So I'm using a random I'm using a random module to create the sets for the solution. Then here to check if it is working, I printed the first 5 solution, it was working. Then we use the reproduction, then we reproduce the solution set. So we take we take ranked solutions, like all the solutions will get ranked. So this ranking of solutions will happen according to the fitness function. So fitness function will rank each thing, and it will give the it will rank each solution, and it will sort it and give it in a reverse manner. Like it will when you sort it, you get it in a descending manner, so you'll keep it in reverse so that you'll get all the things in an ascending way. So here I just put the best solutions of generation I. Like this each time you insert a new offspring into the population, you iterate it again, so there'll be generations. So then what I did is I made a then what I did is I made elements of S. I defined a list called elements. And and like from the ranked solutions, I have cut off first 100 solutions from the ranked solutions, and then I have from for in the append in the elements one, I have appended the best of the cutoff solutions. That way you can create the new generation, uh, up and then append it to the population, which is soul. So here r dot uniform 99 to 1 1.1, this is nothing but the mutation which I have introduced 2% mutation. uh, so there'll be a change in the new generation, and then it will append to this into the solution. So again it will iterate. So it will check for the best desired solution. So I have set the if the rank is more than 999, uh, yeah, I have set it to stop, because we don't want. I wanted it to be at 999, because we don't want more accurate thing. If you want more accurate ones, you can set it to 9999 also. It's not a problem. So once I'll start running this function. So it will start, and at generation 322, it has found the most desirable solution. So I'll just copy this, and we'll check if it is working. Controls. Here we'll check it. Okay. Yeah. As you can see, the answer is close to 0. If you increase this to somewhat like 9999 and run this, and again at generation 351, you get the tuple here. Control C, and here we control V. You see that it is more closer to 0, like minus 3.9 into 10 to the power minus 5, which is more close to 0. So this is how you optimize the solutions for a given function using using genetic algorithm. Thank you. So, do you have any questions here?
Is it over?
Yeah, it's over. Like, do you have any questions?